Hello, and thank you for joining me for my presentation on preparing for blockchain in a new era of smarter food safety. Hi, I'm Kathy Barbeire, Marketing Manager for Cat Squared. For anyone not familiar with us, Cat Squared develops smart factory solutions that automate the plant floor and support continuous improvement efforts for food manufacturers. Our system collects data from all plant floor activities and can integrate that data back into a company's ERP system or display data in real time on plant floor scoreboards or executive dashboards. This gives our customers a full view of all production and inventory movements in real time. In November of 2019, Cat Squared became the first MES provider in the food industry to become an onboarding partner for IBM Food Trust. This will expand the reach of our current MES system to not only deliver full visibility of product movements from within a plant or across an enterprise, but will soon be capable of delivering to our customers full visibility of ingredient and product movements across their supply chains. As part of my role with Cat Squared, I've been representing our company as a participant in a blockchain learning group that has grown out of Blockchain for Arkansas. This is an initiative launched by Governor Asa Hutchinson to promote capacity building around blockchain technology in our state. As part of this initiative, I've participated in work groups with other Arkansas technology companies and blockchain service providers, and these collaborations led to the passing of House Bill 1944 in the Arkansas legislature in 2019, recognizing electronic signatures and blockchain-enabled smart contracts in Arkansas law. So as I mentioned, I'm a marketing manager, and this Dilbert cartoon tickled me because it implies that someone in marketing isn't smart enough to understand blockchain. So suffice it to say, if I can understand blockchain, fear not, you too can understand blockchain. In addition to my role as a marketing manager, I also hold a degree in technical writing. So I'm accustomed to taking technical information and translating it into terms that a layperson can understand. With that said, I am very aware that there are parts of this presentation that get a little dry and technical when I start explaining consensus algorithms. But the reason I keep this content in my presentation is because I attend a lot of conferences on blockchain, but I very rarely see content that clearly describes the technology. It's usually mentioned as a bullet point on a slide as a disrupting driver that's going to revolutionize traceability along our value chains, but with no real explanation as to how this technology really works. And I feel it's important for leaders in the food industry to have a basic understanding of this technology so they can recognize both its applications and its limitations. And this understanding may also address common concerns about privacy and data integrity. So we'll start this presentation with an overview of what blockchain is, how it works, and who the key players are in the current landscape. And then we'll move into practical applications. What's the business case for blockchain? What forces are driving adoption? And what barriers are preventing adoption? And then we'll end with some specific steps manufacturers and other supply chain participants can take to prepare for what the FDA has dubbed a new era of smarter food safety. So first, what is blockchain? Blockchain is a form of distributed ledger technology, which means that it's a shared ledger stored across multiple locations. To illustrate how blockchain is different from the current use of EDI, or electronic data interchange, let's examine how participants currently interact in today's supply chain. As you can see from the top graphic, EDI messages are point-to-point one-way communications. Each party has unique and limited visibility, and therefore each party has their own version of the truth. The lower graphic shows how supply chain participants can contribute EPSIS data to a blockchain. Because the ledger is shared, data is transparent to all permissioned participants within the blockchain. And since the ledger is a type of database that only allows entries to be appended rather than changed or deleted, the data in the ledger is immutable, which means it's unchangeable. And because it's stored in multiple locations, no one participant in the business network can modify the ledger without everyone knowing. This creates trust in the provenance of the ledger, what blockchain providers call security through transparency or trust through transparency. Now, there are multiple blockchain platforms. The two largest next to Bitcoin are Hyperledger and Ethereum. There are several differences between these two platforms, but the main differences you'll probably be concerned with are related to data integrity and processing speed and confidentiality. Before I discuss data integrity, let me explain a little bit about the mechanisms used to build consensus and why this is important. As I mentioned earlier, blockchain is a distributed ledger stored across multiple locations. So each participant owns a full copy of the ledger, meaning there are multiple copies of the ledger stored across a blockchain network. The graphic on this slide illustrates the differences between a traditional centralized database network that most of us are used to on the left and a distributed network illustrated on the right. As each participant on the blockchain writes an entry onto the ledger, all participants constantly have to agree on the true state of the ledger. This process is called reaching consensus, and this is what prevents double spending. So what is double spending? As many of you know, blockchain is the technology that makes cryptocurrency like Bitcoin viable. So when you're sharing files on the internet, it's possible to make endless copies of files and send them to multiple recipients instantly. However, if I want to send $1 to someone, I can't also be capable of sending the same dollar to someone else. And previous forms of cryptocurrencies failed because malicious participants found ways to double spend currency by injecting faulty transactions onto the ledger. So Ethereum solves this problem by using a proof of work algorithm. This is an intensely complex algorithm that requires a significant amount of computing resources to solve. Once a participating node, called a miner, solves the algorithm, they are rewarded with Ether, which is Ethereum's built-in cryptocurrency, and their copy of the ledger is then sent across the network, and their solution of the algorithm is verified by other nodes, and their version of the ledger becomes accepted as the truth. And all transactions stored on that version of the ledger become an immutable block of data on the blockchain. Hyperledger uses something called practical Byzantine fault tolerance to solve the double spend problem. This is a different type of algorithm that requires 2/3 of all nodes, or what they call validation peers, to calculate the same hash code. And I realize that explanation is a little overly technical, but what's really important for you to understand is that this type of validation uses significantly less energy than proof of work, which translates into more transactions per second. So Ethereum can handle upwards around 20 transactions per second, whereas Hyperledger can achieve an end-to-end throughput of more than 3,500 transactions per second. Supporters of the Ethereum platform claim that proof of work delivers a higher degree of data integrity than practical Byzantine fault tolerance. However, Hyperledger is a private permissioned platform, which means that only verified participants can view data, and only participants with special rights can verify transactions on that platform. So users don't face the same level of risk from malicious actors as they would on a public permissionless network. So the bottom line is that Hyperledger has become the preferred platform for B2B transactions because of its speed, scalability, and also its ability to allow for confidential transactions, which is important for suppliers participating in a blockchain project that includes their competitors as part of the supply chain. Currently, there are several food-related blockchain projects in different stages of development. The biggest solutions currently available are IBM's Food Trust, which is designed to meet the needs of grocery retailers and distributors, and Ripe.io's agricultural blockchain, which focuses on freshness during distribution. And both of these solutions run on Hyperledger. Covantis was launched in March of 2020 to develop a blockchain-based prototype for international bulk agricultural commodity trading. The initiative selected Consensus, an Ethereum technology company, to develop its platform. So you'll remember from the table on the previous slide that Ethereum was listed as a permissionless network, which is one of the reasons Hyperledger has become considered the blockchain of choice for business. And so this is an excellent opportunity to point out how the blockchain ecosystem is constantly evolving. As you may have gathered from the previous slide, it takes a lot of electricity to power a blockchain due to the energy required to process the algorithms. Blockchain developers are constantly working on ways to decrease energy use and while also increasing processing speed without sacrificing security and data integrity. So for Covantis, Consensus is building a secured platform on Quorum, which is a permissioned fork of Ethereum and was originally developed by JP Morgan Chase. Now, outside of being a big buzzword, what is the real business case for blockchain outside of the financial services sector? The food industry probably really started paying attention to blockchain technology when Walmart mandated their leafy green suppliers to implement end-to-end traceability back to farm. To help their suppliers meet this goal, Walmart's letter mandating the change referred suppliers to the IBM Food Trust Network, which is a blockchain solution pioneered by IBM to improve food safety. So obviously Walmart sees value in blockchain's ability to limit the scope and scale of recalls. For example, in the case of the E. coli outbreaks linked to romaine lettuce, retailers knew that the source of the outbreak was lettuce from the Yuma growing region, but they had no way of really easily identifying which of their lots were sourced from that region. As a result, the only solution was to pull all lettuce from stores around the country and at significant cost. If all participants along the supply chain had been contributing data to the blockchain, a specific product lot could have been located anywhere along the supply chain instantly, which would have dramatically limited the cost of the recall. But the true business value in blockchain is realized through removal of friction in transaction processes, increased efficiency in transactions, and quick dispute resolution. By using smart contracts, the SLAs of a business agreement are turned into code that lives on the blockchain, automating payments and resolving simple disputes. The way this works is just like with a traditional contract. The terms of the smart contract are agreed to by all parties. And once the contract is finalized, the terms are turned into code that lives on the blockchain and cannot be changed without all parties knowing. So, as a side note, during our learning group meetings, a representative from IBM said that about 40% of time spent on their blockchain projects was spent getting all participants to the table and gathering consensus around the rules of governance for the blockchain. So what early adopters are realizing is that they need to include an expert in dispute resolution as part of their project team to help lay the foundation of the agreements upon which the blockchain smart contracts will be built. So if your company is considering becoming involved in a blockchain project for the purposes of streamlining your supply chain, you should be aware that a significant chunk of your time will be spent on this first step. However, once this step is completed, writing the code and processing the data is relatively straightforward. Now, once the terms of the contract are finalized and turned into code on the blockchain, a triggering event occurs. This could be a shipment of product is received, or a lot passes inspection, or whatever event is defined in the smart contract. And that event triggers the execution of the contract based on the pre-agreed upon terms. So at this point, a settlement process occurs, like an automatic payment is sent or an invoice is generated. And this is where participants along the value chain start reaping the benefits of all the work they put into nailing down the details of the smart contract. Because they worked out ahead of time what would happen with any foreseeable contingency, like let's say a shipment arrives damaged, or too much product was shipped, or not enough product was shipped. Whatever the issue is, the data is logged, sent up to the blockchain where it's visible and verifiable by all participants permitted to view the data, and this event executes the appropriate clause within the smart contract, and the settlement process occurs automatically based on that agreement. By streamlining transaction processes this way, you remove a lot of time wasted disputing the terms of your agreements. And in the food industry, time is valuable when you're dealing with perishable products being shipped or live animals under stress during transport. The more time you can shave off of your transaction process, the more you'll be able to reduce loss due to DOAs and spoilage. And in a real-world example from 2018, a consortium of commodity traders ran a pilot sale of 60,000 tons of soybeans from the US to China on a blockchain platform. They reportedly reduced their document processing time to 1/5 of the time needed to process the traditional physical paperwork. And blockchain can create additional value at the enterprise level. As all plants across an enterprise begin contributing data to a blockchain, managers can do performance comparisons by plant or by product, leading to new levels of insight. For example, data analysis could reveal that there is consistently a problem at plant X on Tuesdays, or there are always long dwell times at plant Y for product B. Insights like these could lead to improved efficiency across the enterprise by identifying opportunities for process improvements and developing incentives for employees to improve performance. But beyond the business case, where is the industry seeing pressure to adopt digital technology? So obviously the 2020 COVID pandemic's disruption of our global supply chain is driving our whole industry to look at ways to automate wherever possible. In Industry 4.0 technologies like blockchain have proven to remove paper, people, and time from processes. And here I want to take a few minutes to look at the current landscape and discuss what's going on with government, retailers, and consumers. On the international front, in January 2020, the Global Forum for Food and Agriculture proposed to establish the International Platform for Digital Food and Agriculture. Key objectives include establishing harmonized policy frameworks and best practices for technology adoption in food value chains. In the US, both the USDA and FDA have put forth proposals pointing to a more digitized supply chain. In the August 5th Federal Register, the USDA's Agricultural Marketing Service proposed amending its rules to include using distributed ledger technology to trace the supply chain of organic products. In July, the FDA released its Blueprint for a New Era of Smarter Food Safety, a campaign intended to strengthen the FDA's protection of the food supply chain. The core elements of the blueprint include supporting tech-enabled traceability, adopting smarter tools and approaches for prevention and outbreak response, developing strategies to ensure consumer safety as new business models evolve and retailers modernize, and nurturing a food safety culture throughout the food system. Prior to the pandemic, the main source of pressure for the industry to adopt blockchain was coming from large retail customers like Walmart, as well as the perceived consumer demand to know where our food comes from. Last November, back when we were still able to attend in-person conferences, I attended the National Conference for Food and Agribusiness at Purdue University. There were a couple points discussed that I wanted to highlight for this presentation that related to how retailers are pushing the industry to respond to consumer needs. First, consumers have many misconceptions about how their food is grown. When asked on a survey whether broilers are given growth hormones, only 8% of survey participants answered that question correctly. Our population is becoming increasingly urban, but consumers still want to feel connected to their food. And today's technology gives us the expectation that all data should be available at our fingertips. So how can food manufacturers harness this technology to educate and build trust with consumers? Another point, because retailers are closest to consumers in the supply chain, they are most responsive to consumer needs, and they're the ones pushing changes in the industry. Additionally, retailers are increasingly willing to go around manufacturers to create the products they need if they can't get the relationship they want with the manufacturer. And therefore, manufacturers who understand and respond to consumer needs are going to win in this environment. One of the most exciting benefits of blockchain for the food industry is its ability to allow manufacturers to connect directly with consumers. Here I'm using a demo version of CatSquared's consumer traceability portal to illustrate how blockchain can help manufacturers build brand affinity. By sharing the story of what makes a safe, quality product with consumers, brands can build consumer loyalty. So by scanning a QR code with a mobile device, consumers can access data about your supplier's certifications and determine whether your products are ethically sourced. They can also, if I can get this to open, find out if the product in their refrigerator is subject to a recall and see the cause of the recall and what they should do. And they can also see live streaming video from the farm where their product was produced, or interviews with members of your team along your supply chain, or who are in charge of your quality control at the plant. So blockchain is creating new opportunities to differentiate between bulk commodities and premium products through value-added data. So what are the barriers to blockchain adoption? The main barriers are apprehension and lack of understanding of the technology, lack of data consistency and common definitions across the supply chain, and continued use of antiquated data collection processes in pockets of the industry. I know our team still walks into plants where most data is collected on paper and spreadsheets. And what are some practical steps manufacturers and suppliers can take to address these barriers? First, understand your processes. By developing a process map, manufacturers can have a visual understanding of processes occurring on their plant floor, what data is being measured during those processes, and how that data is flowing across their network. So using this simplified process map as an example, the bottom layer represents the physical process occurring in the plant's receiving area. The second layer identifies hardware used to take a measurement or control a process. In this case, a truck drives over a scale to capture the gross weight. The third layer represents the data layer, or how data is being recorded and transmitted. This could be by paper and spreadsheets, or this could be by an MES system. In this example, this is where our system pulls the receiving schedule from the ERP to check in the truck, receive the captured weight, and assign a queue number for pre-unload inspection. The data collected from the inspection would be communicated back up to the ERP system in the next step of the process, which is not illustrated here. But having this clear understanding of what data you're gathering and how it flows across your network helps you to identify operational value drivers and develop measurable KPIs for data-driven decision-making. And this is also critical for the next step: adopting common language and common standards. In order for blockchain and other digital technology to be interoperable, common data standards must be adopted across the value chain. The most widely used is GS1, which is used to identify, track, and trace critical tracking events and key data elements. So as I mentioned earlier, EPSIS, which stands for Electronic Product Code Information Services, is a global GS1 standard for creating and sharing visibility event data both within and across enterprises. There are 6 standard EPSIS event types that represent real-world events. A commission is an event signifying the creation of an object, like the birth of chicks, for example. Transformation is an event signifying an irreversible transformation of an object, like the slaughtering of chickens into carcasses. This is an irreversible event. Aggregation is the grouping of objects into a batch, and disaggregation is the ungrouping of objects. Observation signifies that an observation has taken place, such as a quality test. And decommission signifies the deletion of an object. For example, carcasses that do not pass the quality test are discarded, and this event can be represented as a decommissioning. For each event type, 4 dimensions are recorded: when, what, where, and why. And here you can see an example of a transformation event where 2 inputs are creating a new output. In this case, 100 bushels of onions and 50 crates are coming together to create 50 bins of onions. Each input, the onions and the crates, had their own G10s and their own lot ID numbers, and they create a new product lot with a new G10 and lot ID number. So this is both a transformation event and a commissioning event because we've created a new object, the 50 crates of onions. If this were a more complex product, like a batch of chicken nuggets, then you'd have more inputs like chicken, batter, oil, packing materials, etc. Each would have its own lot number and G10, and each would be connected to the new G10 and lot number at this plant identified by its GLN, or global location number. So when you start seeing how standardized data can easily flow across a network, you can imagine how easy it could be to perform a forward or backward recall in the matter of seconds. The next way we can address barriers to technology adoption is by building a culture of knowledge sharing, both inside your organization and outside your organization with your supply chain partners. Leadership and accountability matter. Regularly meet with your plant leadership to establish standards, share best practices, and hold each other accountable. Likewise, meet with your trade partners, discuss your technology platforms, see where you can standardize your data collection practices, and look for opportunities to integrate your traceability data and streamline your transaction processes. This will improve efficiency and traceability across the supply chain. Also, develop strategies to bring value to all supply chain participants. The very nature of this new technology requires collaborative thinking. A blockchain is only as strong as its weakest link. If any supply chain partner doesn't see value in adding an additional cost or an additional step to their process, they will not participate. And finally, develop approaches to educate consumers about how food gets to their table and how to handle and prepare it safely. Take time to build trust. Let consumers know that you care about their concerns for safety, sustainability, and humane treatment, and show them the data to back up your claims. Because as I mentioned earlier, in this environment, suppliers who are most responsive to consumer needs will win. I hope you were able to receive some value from today's presentation. If you have any questions, you are welcome to email me at kathy.barbeire@catsquared.com. You can also subscribe to our monthly newsletter on our website at catsquared.com. Thank you again for attending, and please stay safe and well.